Okay, good evening, everyone. Welcome to the AFour Technologies webinar. This is Rohan Shinde, DevOps engineer. He also manages the Kubernetes infrastructure in AFour. So you might have gone through this slide before, like you have an idea, like who should attend this webinars and who can be part of this growing community of DevOps and what we can expect from these introductory webinars. You might have not gone through the slides, and you can have a look into our LinkedIn account and you will get the information about the same. Okay, so today's topic is DevOps continuous deployment, and we will be looking into the in Kubernetes as an orchestration tool for the containers. So this is the agenda for Kubernetes. So first we'll start with the Docker container and recap, like you might have attended our the last webinar which happened on the Docker, and then we will look into the what is exactly Kubernetes is. Then we will look into the basic and advanced features of Kubernetes. After that, we will take a deep dive into the architecture of Kubernetes, and we will proceed further with the Kubernetes concepts. Yes, the important part of the Kubernetes services. We will also check the types of Kubernetes services. And yeah, after that, and in a stop, we will take a quick demo of how Kubernetes work on the command line. The kubectl overview will take. And in the end of the session, we'll give some assignments which you can solve and send it across to our email ID, and we will get back to you about that. So let's start off the session. I hope I'm able to audible enough. Yeah, good. Yeah. So recap about the Docker. The key benefits of Docker containers: the speed. Yes, it's lightning faster speed. Like no OS to boot, just applications online in seconds. The super portability. The less dependency between process layers, like ability to move between the infrastructures freely. The efficiency, like less OS overhead, and your resources of your hardware will mostly utilized for the applications, and it's improved VM density. We'll also look into some basic Docker things like we have looked into last webinar, like Docker images, a basis of a Docker container, then the container, like image when it is running, the engine, the registry where we store all our Docker images, we push the Docker images, like the official site is the Docker Hub. Then there's the control panel which manages the Docker containers and the cluster orchestration. Okay, so Kubernetes and Docker. So programs running on Kubernetes are packaged as Linux containers. Containers are widely accepted standards, so there are already many pre-built images that can be deployed on Kubernetes. Containerization allows you to create self-contained Linux execution environments. So any program and all its dependencies can be bundled up into a single file and then shared on the internet. Anyone can download the container and deploy it on their infrastructure. So with very little setup is required for that. And creating a container can be done programmatically. So allowing a powerful CI/CD pipelines to be formed. Multiple programs can be added into a single container, but you should limit yourself to one process per container, if at all possible. It's better to have many small containers than one large one. If each container has a tight focus, updates are easier to deploy and issues are easier to diagnose. So why Kubernetes? You might well get a big idea about why we will be using Kubernetes by these messy containers. So here it is, like the Kubernetes, it's open source, portable platform. It can automate the scaling of your workloads. It can group your containers into a logical units. Yes, it's Google's brainchild. Now Google donated it to the CNCF. It's written in Go language, which is very hot in the market now. It's a container orchestration tool. So we'll look into the basic features of Kubernetes. Suppose you want to spin up 5 containers and you want to use a particular image, and you want to place an internal load balancer in front of these containers, or maybe you want to spin up 10 containers and place a public load balancer, or maybe you're running e-commerce sites and on Black Friday or Christmas you expecting a heavy workload on your websites like traffic spikes. Maybe you can grow your cluster on the go without affecting your applications. You can add containers, and once the festive season is over, you can scale it down to save the cost of the resources. Or your developers, you want to release some new softwares, and maybe it's a continuous process of upgradation of your existing infrastructure. So that all can be done with the Kubernetes. So these are the advanced features of Kubernetes, where we can have the auto scaling, the blue-green deployment. The blue-green deployment is nothing but a technique that reduces downtime and risk by running 2 identical production environments called blue and green. So if suppose at any time only one environment is live, with the live environment serving all production traffic. So in this example, we can call the blue is currently live and the green is idle. Then we have the canary deployment. So what is canary deployment? So like a pattern of rolling out releases to a subset of users or servers. So the idea is to first deploy the change to a small subset of servers, test it, and then roll the change out to the rest of the servers. So these deployments we can do by the Kubernetes. Then there is a automated scheduling, like Kubernetes provides advanced scheduler to launch container on cluster nodes. It has the self-healing capabilities where it can do the rescheduling, replacing, or restarting of the containers which are dead. Then it can also you can also do the automated rollouts and rollback. So Kubernetes supports the desired state of the containerized app. Horizontal scaling and load balancing, like the Kubernetes can scale up, scale down your application as per the requirement. So this is the architecture diagram of the Kubernetes, and we will first look at the architecture at a higher level, and then we will drill down into each of these components. So we are going to use an analogy of maybe shifts to understand the architecture of Kubernetes. So let's suppose we have 2 kinds of shifts in the example, 3 kinds of shifts in the example. The cargo ships that does the actual work of carrying the containers across the sea, and control ships that are responsible for monitoring and managing the cargo ships. The Kubernetes cluster consists of a set of nodes which may be physical or virtual servers, maybe on premises or on cloud, so that host applications in the form of containers. These relate to the cargo ships in the analogy. The worker nodes in the cluster are ships that can load the containers. The control ships relate to the master node in the Kubernetes cluster. The master node is responsible for managing the Kubernetes cluster, storing information regarding different nodes, planning which container goes where, monitoring the nodes containers on them. The master node does all of this using a set of components together known as the control plane components. So we will look into each of those components now. We'll start with the scheduler. Like scheduler identifies the right node to place a container on, and based on the container's resource requirement, the worker node's capacity or any other policies constraints such as stains and tolerations or node affinity rules that are on them. In Kubernetes, we have controllers available that take care of different areas. The node controller takes care of nodes. They're responsible for onboarding new nodes to the cluster, handling situations where maybe the nodes become sometimes unavailable or gets destroyed. So the replication controller ensures that the desired number of containers are running at all the times in the replication group. We'll be looking into the replication control in the next coming slides. This is a Kube API server is the primary management component of Kubernetes. The Kube API server is responsible for orchestrating all operations within the cluster. It exposes the Kubernetes API, which is used by the external users to perform the management operations on the cluster. So as well as the various controllers to monitor the state of the cluster, it can make the necessary changes as required, and by the worker nodes to communicate with the server. So the captain of the ship is the kubelet in the Kubernetes. The kubelet is an agent that runs on each node in a cluster, and it listens to the instructions from the Kube API server and deploys or destroys the containers on the nodes as required. The Kube API server periodically fetches the status reports from the kubelet to monitor the state of the nodes and the containers on them. And the last one is the kube proxy servers, which is the service ensures that the necessary rules are in place on the worker nodes to allow the containers running on them. So this is a deep dive into the architecture of Kubernetes. Now let's look into some Kubernetes important concepts. So here's the pod. Unlike other systems you may have used in the past, like Kubernetes doesn't run containers directly. Instead, it wraps one or more containers into a higher level structure called a pod. The pod is the smallest unit into the Kubernetes cluster. Like any containers in the same pod will share the same resources and local network. Containers can easily communicate with other containers in the same pod as though they were on the same machine while maintaining a degree of isolation from others. Pods are used as the unit of replications in Kubernetes. Like if your applications become too popular and a single pod instance cannot carry the load, the Kubernetes can be configured to deploy new replicas of your pod to the cluster as necessary. So even when not under the heavy load, it is standard to have multiple copies of pod running at any time in your production system to allow some load balancing and failure resistance. So pods can hold multiple containers, but you should actually limit yourself when possible, because the pods are scaled up and scaled down as a unit, and all containers in a pod must scale together. So regardless of their individual needs. That leads to wasted resource and an expensive bill. To resolve this, pods should remain as small as possible, typically holding a main process, and it's tightly coupled with the help of containers. Sometimes we call it like a sidecars. So next is the node. Like it is a representation of a single machine in your cluster. In most production systems, a node will likely be either a physical machine in a data center or maybe a virtual machine hosted on a cloud provider like Google platform or maybe in AWS. So don't let conventions limit you. Like, however, in theory, you can make a node out of almost anything. So thinking of a machine as a node allows you to insert a layer of the abstraction. So now instead of worrying about the unique characteristic of any individual machine, we can actually instead of simply view each machine as a set of CPU and maybe the RAM resources that can be utilized. So in this way, any machine can substitute any other machine in the Kubernetes cluster. Okay, so although the working with individual nodes that can be useful, it's not the Kubernetes way. I mean, in general, you should think about the cluster as a whole, like instead of worrying about the state of individual nodes. So in Kubernetes, node pools, which are like, it consists multiple nodes inside the pool. It's together their resources to form a more powerful machine. Like when you deploy programs onto the cluster, it intelligently handles the distributing of work to the individual nodes for you. So you don't need to worry about distributing them. So if any nodes are added or removed, the cluster will shift around work as necessary. It should not be matter to the program or the programmer which individual machines are actually running the code, because it's the whole motor is to get the job done. If this kind of a high mind like system reminds you maybe of the character Bob from the Star Trek movie, you are not alone. Like the Bob is the actually name of the in Google's internal project, which was the Kubernetes based on. So because of the programs running on your cluster are not guaranteed to run on a specific node, so data can't be saved to any arbitrary place in the file system. If a program tries to save data to a file for later maybe use, but it is then relocated onto a new node, the file will no longer be where the program expects it to be. So for this reason, the traditional local storage associated to each node is treated as a temporary cache maybe to hold some programs, but any data saved locally cannot be expected to persist. So to solve this problem, to store data permanently, the Kubernetes uses the persistent volumes. While the CPU and RAM resources of all nodes are effectively pooled and managed by the cluster, the persistent file storage is not. Instead, the local and maybe the cloud drives can be attached to the cluster as a persistent volume, and this can be thought of as a plugin, as an external hard drive, just like you use into the cluster. So persistent volumes really provides a file system that can be mounted to the cluster without being associated with any particular node. In AFour, we have actually moved from using the traditional way of databases on any virtual machines or the physical systems. We actually containerized the stateful databases like MySQL. So I can give you the link to the my GitHub, where I have noted down the steps how you can perform the this persistent volume, how we can claim it. I can take you there. So this is my GitHub repository. You can have the simply it's a YAML files. So you can take a look on it later on, and maybe like this way you can configure your own database into the containerized format. I will give this link into the reference in the last slide. Okay, So next is the replica state. A Kubernetes replica state ensures that the specified number of pods in a replica state that are running at all the times, and if suppose a pod dies or crashes, the replica state configuration will ensure a new one is created in its place. You would normally use a deployment to manage this in place of a replica set. So in the slide, maybe you can see that if the replicas are 3, and then by using this pod template, A, B, C pods are created. So if suppose C gets crashed, then it will be the pod will be terminated, and in that situation, it's self-healing. So by using this replica set feature, the Kubernetes will create a new pod, and it will be up and running without any your manual intervention. And that's the beauty of the Kubernetes. The next thing is the deployment. So although the pods are the basic unit of computation in Kubernetes, they are not typically directly launched on a cluster. So instead, the pods are usually managed by one or more layer of abstraction. That is we call as a deployment. So a deployment's primary purpose is to declare how many replicas of a pod should be running at a what time. So when a deployment is added to the cluster, it will automatically spin up the requested number of pods, and then it starts monitoring them. So if suppose a pod dies, the deployment will automatically recreate it. Using a deployment, you don't have to deal with the pods manually. Like you just need to take care of you just declare the disaster state of the system, and it will be managed for you automatically. So in this slide, you can see that there's a set of replicas defined by users 3, and this A is nothing but the replica set. If suppose you want to change it to the 2, then you just need to change the numeric number into the deployment state file, and the Kubernetes will start creating the new pod set, the replica set. You can see it in the B, and then it will, once that is running, it will delete the older one. So it happens on the go without affecting your application. So no downtime is required here. And if suppose this is not the change you actually want, that you wanted something different, like then you have this option to roll it back to the earlier state that we call as the rollback. So you can simply go back and just open the state file of deployment, just change the number from 2 to 3, and that's it. Then the rollback will start taking its place. It will start creating the new replica sets of having the 3, and then it will delete the older replica set. And here you will achieve the state which you desired. Okay. Next topic is the Ingress. We will just take an overview of it. Will not go deep dive into it because that's kind of an advanced topic, which is kind of out of this scope of this webinar. So what is Ingress? Like using the concepts described above, like you can create a cluster of nodes and launch deployments of pods onto the cluster. So there is one last problem to solve, like however, allowing external traffic to your applications. How we can do it? So by default, Kubernetes provides isolation between your pods and the outside world. So if you want to communicate with a service running inside your pod, and you have to open a channel for communication, and this is what referred to as Ingress. And there are multiple ways to add Ingress to your cluster. The most common ways are by adding either an Ingress controller or a load balancer. So the exact trade-offs between these two options are really out of scope for this introductory webinar. So you must be, but you must be aware of that. The Ingress is something you need to handle before you can actually start experimenting with Kubernetes in your maybe the staging or the production stage. All right, so suppose a developer, is trying to access any raw pod, maybe by their IPs, and let's say one of the pods is crashed, and it will now be recreated. You lost the IP of that pod. So in this situation, it will be very difficult in your application deployment. Like you need to keep changing your IP address according to the new pods. So what is the solution? The solution is the service. Like a service can be defined as a logical state of pods. Maybe it can be defined as an abstraction on the top of your pod, which provides a single IP address and DNS names, like by which pods can be accessed. So with service, it is very easy to manage the load balancing, the configuration. It also helps the pods to scale very easily. So let's say the same scenario, like we have seen before, like the user is accessing the raw pods and now it is accessing through a service. Even let's say in the middle pod, it gets crashed and we lost the IP address of it. We no need to bother because it's all the new one which will get created. It will be automatically binded with this the service. So Kubernetes service is an kind of a abstraction of a logical set of pods. Simply, the service acts as an intermediate which allows pods to talk with each other. The Kubernetes service also supports the TCP and UDP protocols. So you can point the state of pods that needs to be exposed from the service you write. So you can see in the above example that how the service is mapped to a pod using a label. Like here, you can see here in my app. So app is the label we are using here to identify this pod. And you can use any name like here to label. So for example, I can define this as like a Rohan and my app. So then I have to just make sure that use that the same into this deployment file and into the service file so that the both will get binded. Okay, so this is nothing but the types of services. There are three important services we'll look into it, and the first is the cluster IP. This is the default service type. If you don't mention any particular type of IP configuration in your file, the Kubernetes assigns this cluster IP to it. So the service is reachable and visible only this inside the cluster. If suppose you don't want to expose your pod to the outer world, this is the correct service type. For example, you don't want to expose your database to the internet. You can only expose to the cluster pods using this cluster IP. The next type is node pod. When you want to expose your applications to the internet, you can use this service type. The Kubernetes master will provide a random port within the range of maybe typically it starts with the 30,000 to sum up around the 32,000, some 700. So you can provide this range using the hyphen service, maybe hyphen node, hyphen port range. That is a flag you will get into the Kubernetes documentation. It's a really great documentation Kubernetes got, and every Kubernetes node will expose this port. Now you may get a question like, what if you have 4 nodes exposing a port on the service, but the actual port is the only one node. So how Kubernetes identify which node should receive this traffic? The answer is very simple. It's a kube proxy, which we seen into the architecture diagram, which actually plays on the Kubernetes node, and it handles it via IP tables. The next service is load balancer. So you can use this service type to provision a load balancer for your service. Some cloud providers allow the load balancer IP to be specified in the service YAML file. In those cases, the load balancer will be created with the user-specified load balancer port. Otherwise, an ephemeral IP will be assigned to the load balancer. So maybe in the case of AWS, you can make use of the elastic IP so that you will get a predefined IP of your choice. All right, so it's enough talk, and I'll show you a quick demo of how the Kubernetes works. Like maybe we can create a pod or delete something. So maybe I'll take you to the my Google Cloud account. You can, if you want, you can create a mini Kubernetes, which you can install on your standalone machine of your laptop or desktop. It's kind of a lightweight version. You can just get installed and start learning. Or the Google also provides some kind of a free like a credit limit which you can make use of and start practicing just by spinning up your Kubernetes engine. So yeah. Okay, so this is the Kubernetes page of the GCP portal where you can start creating your first cluster by just clicking here. I will not show you the entire step by step because it will take a longer time. So maybe this is pretty simple, like configurations, and you will mention your zone, which area you are located. Maybe you can mention the node codes, like what is the requirement of your nodes. The 3 nodes are default. You can also mention the size of your nodes as per your requirement, and then these are some advanced topics in it, like you can enable the STO or the Anthos, and just create and just wait. Your cluster will be ready in maybe 15-20 minutes of time. So to save the time, I've already created a dummy cluster here, which we can connect. So here is the option. This is the command which you can just try running into the Google's own cloud shell. You can also configure it on your command prompt, which you have native, just opening into the new page so that you will have a great look. This is the fastest way you can get started with the Kubernetes because it's all already pre-configured. You just need to mention your configuration details. Okay, we'll try with the basic commands. So here you can add the first command, which is the kubectl. The kubectl is nothing but the way you can talk with the your Kubernetes. So it accepts the command which starts with this kubectl. You can type in this command and you will get a list of commands which you can try on your machine. If you want to check the pods which already there, now there are no resources. It's a pretty fresh cluster I have created. So maybe what we can do is either I can use the Docker file or maybe I can use any manifest file. So I do have one manifest file ready for demonstration. So this is one very pretty simple manifest file. So you can see that this API version, kind of this kind, it is like pod. If it's a deployment, then you will mention the deployment. Similarly, you can mention the replica set if it's for replica set. Then there's a name I've given to the pod is like hello pod. Then I use the labels to identify it, and it's just simply pulling the image of engines from the Docker registry. So let's go ahead and create our first pod. So the command is pretty simple. It is just kubectl create. I think it is not visible, so maybe. We can hide it. For settings. I think we have hidden it. Now it's pretty simple. Command we will try kubectl create -f. We will mention our pod name, and just blink of seconds, it will start creating your first pod. Now we will see the status of it by command kubectl get pods. Okay, so within few seconds, your pod is running in the running state. You can also check the IP address of this pod and on which node it is running. So the same command, you just need to extend with some arguments like -o void. So here you can see that this node which is getting utilized for this pod. So and this is the IP of your pod. Similarly, this way we can actually see how many nodes are available and what is the status of your node. So you get an idea like kubectl get pods, get nodes, get deployments, get services. These are the very simple commands try out. And if you really forget any command, just take help of the kubectl help commands and you will get the list of commands. I will also show you the describe command. This is very useful when you want to check the status of your pod. Like you will actually see the lot of details here, maybe which node it is running, the starting time, and with annotations, the status is running. If it's not running, it will show some other error message here. It will also show which Docker registry to use, full level 1. So these are helpful details you can utilize for you to check the status of your pod. So that's it. You can try out your own hands-on. Maybe we can give you the assignments. Okay. So these are the references, like the Kubernetes documents. You can go ahead, like if you need some installation help, this is the command, this is the link. If you can check out my GitHubs if you need any help regarding your setting up the containerized database. Then we have some assignments for you. like the last webinar which we have taken on the Docker, so we can actually recap it. What you need to do is just create a Docker file, you just build it, push it, and get it deployed on your Kubernetes cluster, and you can view it in your Kubernetes dashboard. The dashboard is like nothing but just a web-based Kubernetes user interface you can get installed on your machine. And you can send this all your queries and the assignments to this email ID, and we'll be happy to get back to you. Hope this is useful for you. All right, thank you very much. Yeah, have a great day ahead. Bye-bye.